Hi, welcome to Mrs. Park's geometry class. This is chapter 2, section 4, deductive reasoning. Okay, so why? Okay, so when detectives are trying to solve a case, they use techniques like fingerprinting to analyze evidence. When they use this evidence to eliminate suspects and eventually identify the person responsible for the crime. Law of detachment. The process that detectives use to identify who is most likely responsible for a crime is called deductive reasoning. Unlike deductive reasoning, which uses a pattern of examples or observations to make a conjecture, deductive reasoning uses facts, rules, definitions, or property to reach logical conclusions for given statements. Okay. Real world example. Inductive and deductive. Okay, so hold on, let's see if we got that correctly. All right. So inductive reasoning, okay, uses patterns of examples or observations. Okay. Deductive, deductive reasoning uses facts, rules, definitions, or properties to reach logical conclusions from given statements. Okay, so inductive patterns of examples of observations. Deductive use facts, rules, and definitions and properties. Okay. All right, so example 1. Determine whether each conclusion is based on inductive or deductive reasoning. Okay. Each time Katie has worn her favorite socks to a softball game, she has gotten at least one hit. Katie is wearing her favorite socks to a game tonight, so she concludes that she will get at least one hit. Okay, so it is inductive or deductive. So Katie is basing a conclusion on based on a pattern of observations. So she's not basing on any facts or anything. She's just basing on observation and patterns. So this is inductive reasoning. Okay. B. If John is late making his car insurance payment, he will be assessed a late fee of $50. John's payment is late this month, so he concludes that he will be assessed a late fee of $50. So his car insurance payment is late. Now this is based on facts, right? If it's late, it's $50. It's late $50 late charge. So if he's late, then he's going to be charged $50. So it's based on facts. So this is deductive reasoning. Okay. So here's your turn, number 1A and 1B. Okay. Go ahead and tell me if it's inductive or deductive reasoning. Okay. So inductive are based on, let me just write it here for you. Inductive patterns, based on patterns or observation. Okay. Deductive are based on facts, information, no, what was it? Facts, rules, definitions, properties. Facts, rules, definitions, and properties. Okay, so go ahead and do 1A and 1B. Come back when you're done. All right, welcome back. All right, while one counterexample is enough to disprove a conjecture reached using inductive reasoning, it is not a logically correct or valid method of proving a conjecture. To prove a conjecture requires deductive reasoning. So we need actual facts or what was it again? Facts, rules, definition, property. Okay. So one valid form of deductive reasoning is the law of detachment. All right. So here you have if P, then Q, right? It is a true statement, and P is true, then Q is true. Okay. So if a car is out of gas, then it will not start. Sarah's car is out of gas. Therefore, valid conclusion is Sarah's car will not start. This is called law of detachment. Okay? If P, then Q. As long as the facts given are true, the conclusion reached using deductive reasoning will also be true. Okay. So use the law of detachment. Determine whether each conclusion is valid based on the given information. If not, write invalid. Explain your reasoning. So given, if two angles form a linear pair, then their non-common sides are opposite rays. Angle AED and angle AEB form a linear pair. Okay. So if AED and AEB form a linear pair, remember it's a set of lines that form a straight line. So they do form a linear pair. Then, conclusion, ray ED, whoops, let's do that in red. Ray ED and ray EB are opposite rays. Okay, so we're going to identify the hypothesis and the conclusion. And the hypothesis, two angles form a linear pair. That's the if part. Okay, two angles form a linear pair. Conclusion, then, their non-common sides are opposite rays. Okay. So analyze the conclusion. The given statement, angle AED and angle AEB form a linear pair, satisfies the hypothesis. So P is true. So this is true, right? Two angles form a linear pair. And angle AED and angle AEB, they do form a linear pair. So that's true. So by law of detachment, the then part, the conclusion, ray ED and ray EB are opposite rays, which matches Q, is a true or valid conclusion. Okay, here's another example. B, given. If Micah goes to beach, she will wear sunscreen. Micah is wearing sunscreen. Or Micah, okay. Mika sounds more girly. Okay, so if Mika goes to the beach, then she will wear sunscreen. Mika is wearing sunscreen. Conclusion, Mika is at the beach. So the if part, if she goes to the beach, okay, that's the P. The then part, she will wear sunscreen. The given statement, Mika is wearing sunscreen, so this is the conclusion. Mika's, whoops, nope. Nope, okay. So the given statement, Mika is wearing sunscreen, this part right here, satisfies the conclusion P of the true condition. However, knowing that a conditional statement and its conclusion are true does not make the hypothesis true. So just because she's wearing sunscreen doesn't mean she's at the beach. If she is at the beach, she will definitely be wearing sunscreen, but just because she's wearing sunscreen doesn't mean that she's at the beach. So this conclusion is invalid. Invalid. Okay? Alright. So here's your turn, 2A and 2B. Okay. Tell me if the conclusion is valid, if it's true, or it's invalid, not true. All right, welcome back. Here's example 3. There is a funny looking ape staring right at you. Okay, so here's a little example about nature. Determine whether each conclusion is valid based on the given information. If not, write invalid. Explain your reasoning using a Venn diagram. Okay, given. If a primate is an ape, then it does not have a tail. Okay, Coco is a primate who does not have a tail. Conclusion, Coco is an ape. Okay, so if it's an ape, it does not have a tail. Right? Yeah. So Coco is a primate who does not have a tail, so he must be an ape. Alright, so here we're going to draw a Venn diagram. Okay. According to the conditional, an ape does not have a tail, so draw a circle for apes that does not intersect the circle for primates with tails. So here's a Venn diagram with primates. Here's a circle for apes, and then here's with tails. Okay. Since we're only given that Coco does not have a tail, we can only conclude that Coco belongs outside the circle for primates with tails. Okay. So he doesn't have a tail, so he can't be here, but he can be here. So this could put her inside or outside. So just because she doesn't have a tail, she can be a primate without a tail that can be an ape, or she can be a primate that does not have a tail. It's not an ape. Okay. So from the information given, we know that apes are primates that do not have tails. We also know that Coco is a primate that does not have a tail. It is possible for Coco to be a primate without a tail and still not be an ape. Therefore, the conclusion is invalid. So this is invalid. All right, so here's your turn number 3. Determine whether each conclusion is valid based on the given information. If not, write invalid. Explain your reasoning using a Venn diagram. Okay? If a figure is a square, then it is a polygon. Figure A is a square. Figure A is a polygon. So let me know if this is a valid or invalid, and draw a Venn diagram proving this. All right, law of syllogism. I always have a hard time saying this word, syllogism. Syllogism. All right, we'll have to practice more in class. Okay, so law of syllogism. Syllogism is another valid form of deductive reasoning. This law allows you to draw conclusions from two true conditional statements when the conclusion of one statement is the hypothesis of the other. Okay, so this is where you'd have if P then Q, and if Q then R are true statements, then if P then R is a true statement. All right, this will make more sense with the example. If you get a job, then you will earn money. If you earn money, then you will buy a car. Therefore, if you get a job, then you will buy a car. Okay, do you see how it just transfers? All right. It is important to remember that if the conclusion of the first statement is not the hypothesis of the second statement, no valid conclusion can be drawn. Okay, so that means if you get a job, you will earn money. And then if they give you something ridiculous here, like if you work at Walmart, you will buy a car, then it doesn't make sense. So it has to be this conclusion has to be the hypothesis, the condition of the second statement. Then it will be true. All right, so here is a standardized test example. Determine which statement follows logically from the given statements. All right, if you like musicals, then you enjoy theater productions. If you're an actor, then you enjoy theater productions. You see that right there? This should have been right here. Okay, if you like musicals, you enjoy theater productions. Maybe you should have said if you enjoy theater productions, then you are an actor. Okay, anyway, okay, so here, there's no valid conclusion because it doesn't connect, right? This should be here. The conclusion should be the hypothesis, the condition for the second statement for it to be true. But so here, you can't really say anything about it. It's no valid conclusion. All right. All right, so here's your turn. Number 4, determine which statement follows logically from the given statements. If you do not get enough sleep, then you will be tired. If you are tired, then you will not do well on the test. So which one of these is the correct answer? All right, so applying laws of deductive reasoning. Draw a valid conclusion from the given statements if possible. Then state whether your conclusion was drawn using the law of detachment or the law of syllogism. Syllogism. All right. If no valid conclusion can be drawn, write no valid conclusion and explain your reasoning. All right. Given, if you're 16 years old, then you can apply for a driver's license. Nate is 16 years old. Okay. Since Nate is 16 years old, he satisfies that hypothesis P is true, but in the law of detachment, a valid conclusion is Nate can apply for a driver's license. All right, here is your turn, number 5. Go ahead and do number 5 and come back when you're, so this is the last one, and when you're done, you are done. All right, thanks for watching.